In this lesson, we'll look at applications of quadratic equations. In particular, we will use factoring, complete the square, and the quadratic formula to solve quadratic equations from this section. The first part of our notes is a list of geometry formulas that you are expected to know. They're the basic formulas for a square, rectangle, circle, triangle, and a box. We'll need these formulas to help us complete some of the problems. Example 1. A trough is formed by taking a 40-inch by 10-inch sheet of aluminum and folding up the sides x inches from the edge longways. When folded, the trough will hold 480 cubic inches. What values of x will create this trough? I have the picture of the completed trough on the right. Let me show you what the trough starts off looking like. It's just a sheet of aluminum. So it's just a rectangle. And it's 40 by 10. Then we're going to make a fold on both sides. And they're the same. So this is x, and this is x, distance away from the edge. And then the question is, how much does that leave in the middle? How long is this base going to be right here? Well, if the whole edge is 10 inches wide, we take x from one side and x from the other side, we end up taking 2x away. So this middle piece is going to be 10 minus 2x. If I take these measurements and I draw them on the three-dimensional picture on the right, then we know that we have 40 going down the length of the trough. The base here is 10 minus 2x, and the height of the box is the length that was x, that was folded up from each side. So we actually have a box. It doesn't have a top and it doesn't have sides on a couple of sides here, but it is a box and it holds 480 cubic inches. So using the formula from above, the one that you know for the volume of a box, volume is length times width times height. If I plug in some of the values that we know, the length is 40, the width is 10 minus 2x, and the height is x. Let's simplify this. I'm going to multiply the two parts on the right first, the two factors there. 10 times x is 10x, and negative 2x times x is negative 2x squared. Finally, I'll distribute the 40, so we get 400x minus 80x squared. This is the formula for the volume of this box. No matter what we use for x, as long as we can actually form the box. What we want to find now is what values of x will give me a volume of 480. So we'll set this equal to 480. Notice that the equation that we have formed is a quadratic because of the x squared is the highest x power there. To solve this, I'm going to move the negative 80x squared to the left side. I'm going to move the 400x to the left side. That comes over as a negative. And the 480 was already there. It was positive, and that's equal to 0. Here we have a quadratic equation, and we'll solve this one by factoring. The first thing I notice is that I can factor out the GCF. The GCF between 80, 400, and 480 is 80, since each of those numbers is a multiple of 80. That leaves me with x squared, and then 400 divided by 80 is 5, so that's minus 5x. And lastly, 480 divided by 80 is 6. Now we have a much simpler quadratic to deal with. This one factors x and x. And then what numbers multiply to give you 6 and add together to give you 5. That would be 2 and 3. We notice that the signs have to be negative. Then we set each factor equal to 0. 80 equals 0. X minus 2 equals 0. And x minus 3 equals 0. We see that x equals 0 gives us no solution. There's no variable there. X minus 2 equals 0 gives me x equals 2. And x minus 3 equals 0 gives me x equals 3. Now, dealing with these application problems, and particularly geometric problems like this, we do need to check to make sure these values are valid. So I'm going to check both of them. So first off, x equals 2. When x is equal to 2, mainly what I need to check is to make sure I can actually form the width of this box. That's the formula 10 minus 2x. So the width would be 10 minus 2 times 2, and that is equal to 6. That makes sense. I can have a width of 6, no problem. So if the width checks out, then the rest of the formula will check out. So x equals 2 works. And now what about x equals 3? It would be 10 minus 2 times 3, which would be 4. And that makes sense as well. We could have a width of 4. What you're looking for here is values that would not work. For example, now this did not come up, but suppose that this had come up as x equals 7. Suppose we did get this for an answer. Then the width would have been 10 minus 2 times 7, which is equal to negative 4. Well, it doesn't make any sense to have a width of negative 4. So if you ended up with something that didn't make sense like this, you would have discarded that solution, and x equals 7 would not have worked. Again, that's just an example to see what it looks like if it does not work out for us. On page 2, let's look at example 2. One leg of a right triangle is 3 less than the hypotenuse, and the other leg is 6 less than the hypotenuse. Find the length of all sides. We'll go back to a couple of lessons where we gave you the list of things to do when dealing with problems. One of those was to draw the picture and declare the variables and things. We'll go ahead and do that here as well. The picture is a right triangle. I don't know exactly what it looks like, so I'm just going to draw a prototypical right triangle. We know that the two legs are both based on the hypotenuse. One leg is 3 less than the hypotenuse. The other leg is 6 less than the hypotenuse. So it makes sense to declare the variable x to be the length of the hypotenuse. We'll add that to our picture. Next, one of the legs is 3 less than the hypotenuse, so that's x minus 3. The other leg is 6 less than the hypotenuse, so that's x minus 6. X minus 6 is the shorter of the two lengths, so we'll call that the short leg, and x minus 3 the long leg. And we mark our picture appropriately. Next, we need to recall which formula is the model that controls the sides of a right triangle. And of course, that is the Pythagorean theorem. Pythagorean theorem says a squared plus b squared is equal to c squared, where a and b are the legs, and C is the hypotenuse. I'm going to substitute the values for our sides into the Pythagorean theorem. So we're going to have x minus 6 squared plus x minus 3 squared is equal to x squared. Multiply out each of these parts. So x minus 6 squared is x squared minus 12x plus 36. X minus 3 squared is x squared minus 6x plus 9. And that is equal to x squared on the right side. Again, we have a quadratic equation because the highest power of x is 2. To solve a quadratic, we move everything to one side. So I'll move the x squared from the right over to the left. When it comes over to the left, it cancels with one of the x squareds. Combine like terms, so we get x squared. Next, for the x's, we have minus 12x and minus 6x. So that's minus 18x. And then 36 plus 9 is 45. For this problem, I'm going to use complete the square just to practice completing the square. So we'll write this as x squared minus 18x plus blank plus 45 blank equals 0. To complete the square, we take half of the b term. So that's 1/2 of 18, which is 9. And then 9 squared is 81. So we'll add 81 there. There was no, the lead coefficient was 1, so we don't have to do anything special here. We just subtract 81 from the other part. Of course, this factors as x minus 9 squared. 45 minus 81 is minus 36, equal to 0. Now we'll solve this, moving the 36 to the other side. Take the square root of both sides. We get x minus 9 is equal to plus or minus 6. Move the 9 to the other side. We get x equals 9 plus or minus 6. And split this up to give us our two solutions. X is equal to 9 minus 6 is 3. And x equals 9 plus 6 is equal to 15. Again, we need to do the check. So first I will check x equals 3. And what I'm checking here is to make sure I can actually form this triangle. One of the sides of the triangle, in particular the short leg, was x minus 6. So x minus 6 would be 3 minus 6, which is equal to negative 3. And of course that doesn't make any sense. We can't have a side of a triangle be a negative number. So we have to discard x equals 3. Next, let's check x equals 15. Here the short leg would be x minus 6, which is 15 minus 6 equals 9. And the long leg is x minus 3. That would be 15 minus 3 equals 12. Both of these check out and work. And in fact, the problem asks for the 3 sides. So the sides are 9, 12, and 15. One of the physics properties and equations that we use with quadratic equations is the vertical position of a projectile. So anytime we throw something, we can model the height of the projectile, whatever it is we're throwing, with one of these equations. Now, this particular model is used when we throw something straight up and it's only being affected by gravity after we release it. The height s of an object thrown straight up is given by s is equal to negative 1/2 g t squared plus v naught t plus s naught, where t is the amount of time since the object was thrown, v naught is the initial velocity of the object, s naught is the initial height of the object, and g is the acceleration due to gravity. Now, depending on the problem, whether or not the units in the rest of the problem is given in feet and seconds or meters and seconds, you'll need to choose the correct value of g. G is either 32 feet per second squared or 9.8 meters per second squared. You are responsible for knowing this formula. Example 3. A rock is tossed straight up from the roof of a 120-foot tall building over the edge with an initial velocity of 8 feet per second. How high is the rock after 2 seconds? So to solve this problem, we first need to create the model. Based on the formula above. So we have s is equal to negative 1/2. We notice that the units used in this problem are feet and seconds. So for g, we'll use 32 feet per second squared. T is the variable, time, so it's t squared, plus v naught is the initial velocity, so that's 8 feet per second, so we have 8t, plus s naught, the initial height, which is 120 feet. That's basically the model. Let's simplify a little bit here. So we get s is equal to negative 16 t squared plus 8t plus 120. Now, we want to know the height of the rock after 2 seconds. So when t is equal to 2, we have s is equal to negative 16 times 2 squared plus 8 times 2 plus 120. And if you use your calculator to figure that up, that's 72 feet. Notice that the feet units come from the other units being used. 120 feet, 8 feet per second. In part B, how long does it take for the rock to be 40 feet above ground? So this time, 40 feet above ground is the s value. S is equal to 40. So we'll take 40 and set that equal to our equation. Negative 16t squared plus 8t plus 120. So here we have a quadratic in the variable t. To solve the quadratic for t, we need to move everything so that we have 0 on one side. I'm going to move the 40 from the left to the right, leaving a 0 on the left. This gives me negative 16t squared plus 8t plus 80. We can use the quadratic formula to solve for this. So that would be t is equal to negative 8 plus or minus the square root of 8 squared minus 4 times negative 16 times negative 80, all divided by 2 times negative 16. I'll use the calculator to compute this. So we have And since you're doing a fraction, start with parentheses for the numerator, negative 8. For plus or minus, I have to choose one of them to do first. I choose plus, square root, parentheses, 8, close parentheses, squared, minus 4 times negative 16 times 80, close the parentheses for the 80, close the parentheses for the square root, close the parentheses for the numerator, divide, and then open a set of parentheses for all of the denominator. 2 times negative 16. Close the denominator, press enter, and you see one of the answers here is negative 2. This answer doesn't make any sense because it would indicate that we went back in time, and this model measures the height of the rock after we release it, which is time equals 0. So we have to discard t equals negative 2. Now, to get the other answer, we need to use a minus. You can use this shortcut on your calculator to second entry is above enter, and it pulls the previous calculation back up. Then use the arrow keys to scroll over to the plus sign and change it to a subtraction sign. Pressing enter will give you the next answer. So you don't have to retype everything. So we get t is equal to 2.5. That's 2.5 seconds. And that's our answer.